So one of the advantages of having a text is you're getting ready to take a test and go to the end of the chapter and you see these key concepts. You could go down, yeah. Okay. You could come down through here and say, well, what do I remember? Yeah, it's a quadratic, I know. Vertex form, yep, I'm good with that. I had to complete the square, do all kinds of stuff. Once it was in that form, I knew the H and the K were parabolas. And you could start to read down through here and what do I know and what don't I know? Can I read the math and understand what's going on? You know, this was the X term and this was the Y term. And that was craziness, but we did something along those lines. We got into polynomials. Okay, and we talked about if the degree was even, how it went and up as long as that leading coefficient was positive. And if the leading coefficient was negative, it opened down. I had a parabola that opened down. So, you know, you could start going through these and say, heck, I don't remember that. And you may have to go back and take a look at some of these things. We talked about zeros and their multiplicity, you know, and an example was x minus 1 squared. Okay, I have a 0 at 1, and because the multiplicity was even, I knew that it touched the graph. If it was an odd, I knew that at 1 it would cross the graph. That's one of the things we're going to be using today and build upon it. We did division. We did long division, which we learned, yeah, that doesn't go away because when I'm doing my slant asymptote, I need to remember how to use that. Then we switched over and said, oh, we had this remainder theorem. And then we also had synthetic division. That was a big thing going on. We came down and we had the zeros, right? And I call these the good guesses, the P's over Q's, and then we could plug those in. So, you know, you just keep going down. Conjugate, yeah, if A plus BI is a root, then A minus BI was a root. We did Descartes' rule of signs, and none of you remember that. Hopefully some of you do. There was something on upper and lower bounds, but we didn't cover that. You know, and then 3.5, this was the last section. We looked at vertical asymptotes, horizontal, and then we had that third case if it was a slant. And so the book isn't awful, and you know, don't be afraid to grab it and look through it, especially right before a test. It's good to have available. All right, so as I was going through there, the one topic I mentioned, some of you are going, yeah, I'll just get that one wrong maybe on the test. Descartes' rule of signs. Let me readjust my camera because I had it up for the book, and I know you all like it when it's a little closer. Descartes' rule of signs. So there's this guy, Descartes, Rene Descartes. I think his first name is Rene, I'm not positive. But he said, I can look at this current function and I can tell you about the positive roots. You know, I can say there might be so many or so many. And what he did was, if you remember, he counted the sign changes. So from negative to negative, nope, that was nothing. From negative to positive, there's 1. From positive to positive, nothing. From positive to negative, there's 2. And from a negative to a positive, there's 3. So what he said was, hey, I know that there's going to be 3 positive solutions, right? Positive. My answer is going to be x equals positive 2, x. He knows that there's going to be 3. But then he learned later that, oh no, there's also imaginaries. And when I want to know the possible solutions, I need to know how many are positive, how many are negative, and possibly imaginary. Okay, so I say there's 3 positives, but I'm going to also say or 1, because I'm going to subtract 2 because there could possibly be imaginaries that I didn't look into. Now, he also took f of negative x because that helps with the number of negatives. All right, so he took this equation, -4, put in -1, or excuse me, negative x to the 5th power minus negative x to the 4th power plus 3 to the negative x cubed plus negative x squared minus negative x plus 1. And what ended up really happening was wherever there was an odd, the sign changed. So this became positive 4x to the 5th. Negative x times negative x times, that's x minus x to the 4th minus 3x cubed, plus x squared. Okay, I think I'm getting it there. Plus x plus 1. Now he went through and counted the sign changes. Positive to negative, there's 1. Negative to positive, there's 2. So now for the negatives, he said, okay, if there's one negative number, I definitely know there's going to be a second one. But it's also possible there's 0 because we're going to subtract out imaginaries. Okay, so I have lots of possibilities of what's going on here with my answers. 3 positives, 2 negatives, 3 positives, 0 negatives. My next combination, 1 positive, 2 negative, and 1 positive, 0 negative. Well, because this is the 5th power, I know there's going to be a total of 5 possible roots. 3 and 2 and 0 makes 5. 3 and 0 and 2, that's good because imaginaries always come in pairs. 1 and 2 makes 5. 1 and 0 and 4 makes 5. Good at 4 because they always come in pairs. So some things that he learned. If there's a positive, and then I go and find a negative positive, I know there's going to be a third positive. So if he started and he said, okay, I have -4, -1, 3, 1, -1 and 1. And he said, oh, I'm going to do my good guesses and I'm going to put a number in there. And if I put in -2 and it works, whoa, I know there's going to be a negative number because I either have 2 answers or none. Just a little help. We had all those good guesses, those P's over Q's to help me. But that was Descartes' rule of signs. I hope that cleared it up for some of you. Maybe, maybe not. But there's an example. Any questions? There's 14 of you in here today. I must have done a good job of teaching it because there are no questions on that. All right, we'll just keep moving along. We'll just keep moving along because we will cover everything. Some instructors, they don't cover everything. That's just not fair to the students. Today, let's see the title. Polynomial and rational, oh boy, inequalities. That means everything that I've been doing up to this point, I'm now going to do with inequalities. Less than, greater than, less than or equal to, greater than or equal to. Oh yeah? Yep. Okay, so let's see what's going on. Boy, oh boy, oh boy. It says, rearrange the terms of the inequality so that one side is set to 0. Bam, big asterisk. Start out by getting it equal to 0. That's huge. Then we want to find these boundary points, okay? I used to call them hot spots when I first started teaching, because something's happening at those points. So let's take a look at this guy, see what we mean by boundary points. Well, down here, I know, oh, this was really nice because it's greater than 0, right? I got one side equal to 0, and I factored, and I know my boundary points are 2, because if I set that equal to 0, and -3. So something big is happening there. All right, so I'm going to come back up to this one. Easy peasy. I'm going to try to remember this as being, what if it was just equals 15? How would I solve it? Well, I might do something like x squared minus 2x is still less than or equal to 15. Subtract 15. And I'm going to factor this. I'm going to factor this. Yeah, this would be much better in a classroom because I'd holler, so-and-so, what is it? And they would respond right away. Now everybody's like, how do I unmute? Where do I go? It's what button? Did y'all know you can unmute temporarily by holding down the space bar? Nina says yes, good. See, that's what's missing. I don't know if people agree or not, but if I see one student shaking their head yes, one, I know you still can hear me. And so I gave you some time. X minus 5, x plus 3. Man, why wasn't I better at factoring way back when to get ready for today? So now I know something is happening at 5. I know something is happening at -3, and these are called the boundary points. If I look at this, x squared minus 2x minus 15, if I set that equal to 0, I know that this is going to be the graph of a parabola. This is positive, it's going to open up. So all that graphing stuff's going to help me now because pow, pow, pow. I needed this point right here, the -3. I needed this point 5, and I know that it opens up. Now, this x squared minus x minus 15, that's like my y equals kind of deal. Okay. And I want to know when my y's are less than or equal to 0. So if I come over here and I say, when is y less than or equal to 0? I'm talking about all of those values. I'm talking about the values from, and it's less than or equal to 0, from -3 to 5 inclusive, because it's less than or equal to 0. Final answer, there it is. We are looking to find out what makes this true. What makes it true is all of the values from -3 to 5. Oh, it's not so bad. If I can graph it, I want the values where my y is less than or equal to 0. Cool. This graph, I know I have a root at 2 because it has a degree of 2. It's even, so it touches. Boom, it touches. I have a root at -3. Boom, it's to an odd power, so it crosses. This is an x cubed, right? If I multiplied all these together, it would be like an x cubed. There's 3 of them. It's positive, so I know it opens this way. So boom, there's the graph. I don't know why I keep saying boom today. I said, oh, boom, chicka boom. All right, so I want to know, when is it greater than 0? What are my y values? Again, think of this as y equals this. When is y greater than 0? Well, let's see. I know that point there is -3. So it's greater than 0. I'm not including 3 though, because that equals 0. So it's -3. These are all positive. These are all positives, all the way up to 2. But 2 is not a positive, so I don't include it. So I have to stop my inclusion. And now I'm going to say union with from 2 to infinity. Bam. I like bam better than boom. Boom. What you think about that? Olivia, can I get a thumbs up? Nope. Sergio, can I get a thumbs up? All right. I don't have a Sergio. Kaylee, can I get a thumbs up? Thumbs up. Thanks, Olivia. Thumbs up. All right. Good. Good. All right. Page 1. That's good. We only have a couple of pages today. I know, right? Okay. 3, 4, and 5, they all kind of go together. Again, I'm going to go through and work it because I'm going to assume I don't have the graph. So I'm going to just slide that over there for a minute. And this one is less than or equal to 0. Here, my y's are less than 0. Here, they're greater than or equal to 0. So let's see if we can tie all 3 of those together. But let's solve number 3 first. I'm going to pause the recording and give you like 2 minutes. All right, anybody factor this?
2x minus 5.
Yeah.
And the same thing.
Oh, okay, cool. Because I can write that as 2x minus 5 squared. Now I know when I set what's in parentheses equal to 0, I get x equals 5/2. I know that it's a double root. So on my graph, it should come down and touch at 5/2. And the graph they give, it does come down and touch at 5/2. Okay, so I want to know, when is it less than, when are my y's less than or equal to 0? It's never less than. It's equal to 0 at 5/2. Final answer is just 5/2. When is it less than 0? When are my y's? Never. Empty set. When is it greater than 0? Negative infinity to positive infinity. And well, I messed that up. With infinities, we put parentheses, not square brackets. Oh, that one's a little different. That one's a little different. Any questions?
How did you get that for this second one?
For the second one?
Yeah.
Okay, when are my y values less than 0? If I look at this graph,
Yeah.
where never.
Oh, it doesn't have.
Yeah, there's none. So that's called the empty set.
Okay.
That's called the empty set. Yeah.
And then negative infinity and positive infinity.
Because my y's are going to be positive. All these are positive
Yes.
y's or equal to 0. Because that was the other part of it, equal to 0.
Okay.
Rocking and rolling. Okay.
Are we required to write down in the set form in test?
You can put the there should be a palette.
Yes.
And on the palette you should be able to see it.
Okay.
And remember, I go through and grade them by hand anyhow. So I will always take a look at it if it's marked wrong and you meant the same thing. Yeah. Uh-oh. So much for polynomials. Now we have the rationals. There's that word rational again. Rational. Ratio. I have a ratio. And yeah, I know how this looks. Because one of the things right away is I know that at 4, I have an asymptote. And that means when I'm trying to figure out how to solve this, that guy's going to come into play. All right, so I have a graph, and let's see, what are my boundary points? What are my boundary points? Well, they're going to come into play up here, right? When my numerator, so I have if I look at x minus 1 and x plus 3, I know something is happening at positive 1, and I know something is happening at negative 3. There are my boundary points when the numerator is 0. If I come over and look at the graph, yep, here's negative 3, here's positive 1, and something is definitely happening there. So as long as I'm able to get the graph, this is great. Quick review. This does in fact look like a slant asymptote, doesn't it? Why not quick review? Okay. This becomes x squared minus 4x minus 3 over x minus 4. And when I was doing asymptotes, I said when this equals 0, we have a vertical asymptote. When this degree is bigger than this degree, I do the division. I take x minus 4 divided into x squared minus 4x minus 3, multiplied by x, I get x squared minus 4x. Subtract is the same as adding the opposites. 0, 0, 0, 0. So this is actually y equals x is my slant asymptote, because I bring down negative 3 and x doesn't go into negative 3. So my slant asymptote is actually the line y equals x. No, it's not. I messed up. Right steps. X squared. This should have been x squared plus 2x minus 3. I'm sorry. I multiplied wrong and somebody was just about to tell me. So now I take x minus 4 and divide in to x squared plus 2x minus 3. Sorry about that, folks. I get x squared minus 4x. I subtract, which is the same as adding the opposites. Now I have 6x minus 3, so that would be plus 6. Should be y equals x plus 6. Yeah, see how that's up at 6? I looked at the graph and realized it was wrong. Y equals x plus 6. But anyhow, that was my slant asymptote. Back here, 1 and negative 3. If I'm able to look at the graph, when is it less than or equal to 0? It's going to be equal to 0 at negative 3. It's less than, oh, I can't write it that way. It's less than from negative infinity all the way up to negative 3. Here's all my less than values. Then I'm going to say, yep, and then at 1 to my asymptote, which was 4. Holy cow, that one wasn't so easy. Negative infinity up to negative 3. Boom, good. From 1 to, as I get really, really close to 4, but that's my asymptote. Wow, we put a lot of what we previously learned into this. Some of which includes just how to write these. Madison, what do you think about that? Oh, yeah. Radhika, what do you think about that?
Which one? The one that we just did?
Yeah.
I know we did a lot in the past, and it
Yeah.
just takes time to recall.
Yep.
Mhm.
What's the very first problem with this problem? What's the very first problem with this problem? Yeah, I think I said that right. What's the problem with this problem?
Less than, we have to get rid of 3.
Yeah, it's got to be 0. What's the problem with this problem? It's got to be 0. It has to be 0 on that right side. All right, so I'm going to pause it. I'm going to put you in pairs so you two, you can discuss it a little bit and work on 7 and 8, and then I'll bring you back in about 10 minutes and I'll have a solution ready and we'll walk through it. Okie doke. So I'm going to create some rooms now for the third. Somebody snuck out already. How the heck can somebody sneak out? Okay, rooms are created. I will see you in about 10 minutes. Give these two a try and see what you can come up with. All right, it looks like everybody's back. So let's take a look at 7. See, you know, scribbling stuff down sometimes helps. You may not know what you're doing, but all right, so we're going to get to 3 alone, or excuse me, the right side to become 0 and move 3 over. When I bring it over, I know I have to get a common denominator, top and bottom by x minus 7. I do know something's happening at 7, right? Oh, there it is. There it is. Boom. X equals 7, vertical asymptote. Got it. Keep going. Distribute the -3. I get -2x plus 16 over x minus 7. Oh, wait a minute. These numerator and denominators both have degree of 1. So I'm going to have an asymptote at -2 over 1, which is -2. Oh, there it is. Making sure this graph makes sense. Here's the -2. Here's the 7. At this point, I may pick points like we did the other day to help me come up with the graph. That's fine, picking points. But right now I have this action going on. Cleaned it all up. I want to know when it's negative. My graph helps. It's negative all the way up to that asymptote from -infinity to 7. And then it looks like it's positive, but it's going to cross at that point. There's that point, 8. So from 8 to infinity, not including 8, it's also going to be negative because my graph is going to come down and it's going to get really close to that asymptote, but it's never going to touch it. Wow. If you got that, give yourself a pat on the back because that was putting some things together that we had to take. And here it is. Once I got to this point, you know, which is also this point, once I got to this point, I'm saying there's an asymptote at 7. There's an asymptote at -2. So if I wanted to look at the graph, I'd have to pick some points to see how this behavior goes. And I got it. I hope some of y'all got it. That's like getting to high level thinking in here. That's quite a bit in there. Coming up with the graph and then analyzing the graph. This next one, I don't know if any of you had a chance to work on it or not, but I started out by cross multiplying. And I got to this point and I was like, well, y equals -x minus 20 is greater than 0. So I had some scratch work going on there. And, I'm like, okay, do I need the graph? So I started thinking, what does this graph look like? But then I still wasn't sure if I was allowed to cross multiply. I came down here and I said, okay, I'm going to do what we did before. I'm going to bring the other term over. And now I'm going to get common denominators. And there's my -2x minus 20 again. But I have it over x plus 6x minus 2. So I know I have something going on at 6 and at -2 kind of deal, or excuse me, -6 and +2, I have asymptote. So I'm still just writing a lot of stuff down, trying to come up with something. And, I get to here and I'm saying, okay, the degree is smaller here than here. So I know I have an asymptote at 0. So now I'm thinking, well, that graph wasn't right. And they didn't give me a graph. And wait a minute, I had to go back and solve for X, right? So when I solve for X, I take a look and I go, okay, so I got to this point in my numerator and it was greater than 0. And I added 20 and I went, oh yeah. When I divide by a negative, I switch the signs. So X less than -10 actually works here. I don't like this problem because there's a whole lot going on. And we're okay with X is -10 because -6 was an asymptote, doesn't affect my answer. +2 is an asymptote, doesn't affect my answer. So do I like this problem? No. But it's on there.
So are we allowed to cross multiply then?
Yep. Yep.
Okay, that's way shorter than doing all of that.
Yep. But you have to remember -6 and +2 would be asymptotes.
Asymptote, yeah.
Yeah, so I got lucky because I didn't need to worry about it because I have X is less than -10 for my answer. So if I was to next time, because there's just a lot going on there. Okay, so I'm looking at number 9 and I'm going, oh no, that's a lot of words. Fumio is constructing a circular koi pond in his backyard. What range of values may he have for the diameter of the pond? I should come back up just a little bit. For the diameter of the pond, if the area is to be no more than that, what is the largest possible diameter? Boy. I have, what is the values that may he have for the diameter of the pool? All right, so first of all, I'm going to draw a pool. Okay, and I know I have a radius. It's a circular koi pond. I have some fishes in there, kind of deal. They're swimming, they're happy, all kind of stuff. Pretty bad fish, but that's okay. So first sentence, Fumio is constructing a circular koi pond in his backyard. So that sentence, you can kind of go because you just told me it's a circle. What range of values may he have for the diameter of the pond? Okay, I know diameter is the same as 2 times the radius. So what values may he have for the diameter of the pond for the area to be no more than 78.5 square feet? All right, I have a formula for area equals pi r squared. And what range of values may he have for the diameter? Let's work with this. The area is to be pi r squared is to be less than 78.5 square feet. So I'm going to find an R, and I'm going to be able to use that R and plug it back in to find my D. So what range of values? Okay. Solving this inequality. R squared is less than 78.5 divided by 3.14. R squared is less than, what is 78.5 divided by 3.14? According to my phone. 25?
Yes.
25. Oh, that's kind of nice because I want this to be less than 25. And what I take the square root. Yeah, yeah, because that's 25, that's nice. So I need a radius that is going to be less than
5.
5. So What is the largest possible diameter? Diameter equals 2 times that 5. Diameter
10.
equals 10. Yeah. No more than 10 feet across. Yeah, it wasn't so bad. The cost C in dollars to produce X items. It's my cost function. We talked earlier about a cost function and a revenue and some other ones. Cost function, if the cost is to be kept below $20, how many items can be produced? So my cost function is this, and I want that less than $20. My cost function, 0.5x plus 150 over x has to be less than 20. I am solving for x. Anybody have any ideas how to do this? Yes, no, maybe?
Could you subtract 20 on both sides?
Yeah, I'm gonna subtract 20, 0.5x plus 150 over x minus 20 is less than 0. Good start.
Could you try to get a common denominator then?
Yep, well, you can get a common denominator. One of the things I already have an alert on is I need to remember x cannot equal 0
Yeah.
just because of the original equation. So now I need to solve for x. So here's what I'm gonna do. I'm gonna let you work on it on your own. You send me your answer in the chat and I'll say, so-and-so, yes, that's correct. You're done for the day. Have a good weekend. Okay, so I'm gonna stop the recording. Somebody watching the recording, they're going, but I don't know what the answer is. I know.